Hello, my name is John Thornton, and I'm going to talk about using coupled CFD and material response codes to simulate the Mars Science Laboratory Mars entry. The objective of this work is to showcase and analyze this coupling in preparation for Mars 2020 post-flight analysis. This work represents an important milestone in validating predictive capabilities for designing thermal protection systems. The coupling process is shown down here in Figure 2. First, the aerothermal properties are computed in the data parallel line relaxation or Doppler code, and then used with the non-equilibrium air radiation or neck air program to compute radiative heating. With the outputs from these codes fed into PATO with a fixed blowing correction, the pyrolysis gases are then computed along with the material response. The pyrolysis gases computed with PATO are fed into Doppler in a blowing boundary condition. The results from this simulation are fed into neck air again to provide an updated radiative heating estimate. The results from both the updated Doppler and neck air codes are then fed back into PATO with no blowing correction put in. Steps 3, 4, and 5 are then repeated until convergence in surface temperature is obtained. The blowing correction equation for the initial iteration in PATO is applied via this equation. The equation relies on a blowing correction parameter which is given by the user and designated by lambda. It also relies on the non-dimensional pyrolysis and char blowing rates. In this study, the char blowing rate is set to 0 for simplicity. The coupling process has been performed up to 65 seconds after the entry interface, with ongoing work to continue marching in time. Differences in the temperature at the heat shield surface between the coupled and uncoupled simulations are not insignificant, and it is expected that these differences will increase as we get closer to peak heating. Thank you for listening, and feel free to ask me any questions you might have.